Nowadays, we live in the middle of phase 4 of industrial automation using data to create information. This evolved phase of automation is called Industry 4.0, and its vital technology is the Industrial Internet of Things, or IIoT. Industry 4.0 combines physical operations with intelligent technologies and big data to create a more comprehensive manufacturing environment. So, if industrial enterprises look for game-changing operational effectiveness, they should invest in and embrace the Industrial Internet of Things, or IIoT. What is IIoT? It is an industrial framework in which physical devices and machines are connected via a network and interact with industrial applications through the cloud. Now let us look at where the IIoT solution is needed. As a quick tip, please subscribe to the channel and like the video. Where you want to get rid of paper information that is passed during shift changing and have a unified data space to digitize information. Where you want your team members to be up to date and well informed on planned processes and be aware of current business and manufacturing procedures. Where you want to increase productivity and profits and enhance client pleasure and experience. Where you want to be ahead of the pack and have a better position than competitors in the market. And where you have difficulties finding candidates to fill open positions at your company, using IIoT is the best solution. Now let us learn about IIoT architecture and the key components that make up this kind of control system. The edge layer consists of physical components such as sensors that extract processes data and actuators that control processes mechanisms. The network layer includes IoT gateways, edge routers, or IoT PLCs that act as a bridge to forward and navigate data within the factory. The cloud layer is the processing engine and data handler, so we call it the core of the IoT system. Here we have a unified data space to store all data and compute them for further use. And at last, there is the application layer. It includes computer-driven industrial applications that manipulate and process the collected data to offer specific services. Please note, the IoT system can also have other levels and components. Here we just mentioned the main ones that are existed in every IoT control system. Now it's time to dive deep into how the Industrial Internet of Things works and how it creates a connected solution. At the bottom of the diagram, sensors act as measurement devices to sense and capture process parameters. Data is then broadcast across a network in the factory easily to reach edge controllers. When edge controllers get data, they serve as the bridge connecting the local network to the cloud. The edge controllers use OPC UA or MQTT protocols to pass data to the cloud since they are open protocols and are manufacturer independent, which facilitates IIoT adoption and integration. After the data has been stored in the cloud, you will have the power to monitor and control operations, analyze statistics on industry performance, anticipate upcoming behavior, especially for use in maintenance, and use advanced capabilities such as machine learning and artificial intelligence. Now let us get familiar with the most significant benefits of the IoT system that attracts nearly every industry toward it. Monitoring the real-time performance of installed equipment within the plant is essential to every industry's existence. It helps engineers make decisions based on real-time data, not the data from yesterday, in generating insights and concrete actions. If any machinery operation across a plant faces alarm conditions, the alarm data is sent to the cloud. Then the information is passed to monitoring systems to deliver immediate alerts to relevant personnel. Thanks to the IIoT solution, this hardware can offer more informed decisions made at the appropriate moment to keep the factory functioning and lower staff stress. If your plant equipment is located in areas such as deep in a mine or among a valley in the mountain where it is hard to access, you can monitor your equipment status using the Industrial Internet of Things. Another significant benefit of using the IIoT system applied in the industry is predictive maintenance. In this method, the IIoT monitors a tribute to keep track of your equipment's health and set warning and alarm thresholds. Upon exceeding the warning threshold, the IIoT sends notifications to the maintenance team to schedule a service for a particular machine and fix the issues before the equipment failure occurs. This way you can decrease unexpected plant downtime. And finally, if you want to optimize production, you can count on two advanced technologies in the IoT system: machine learning and artificial intelligence. Machine learning is where it learns techniques and processes on its own despite not being programmed to do so. And AI is where it can carry out actions and make choices that traditionally need human intellect. It's crucial to know about the potential risks of implementing IoT before you decide to embrace this system with open arms. You are dealing with a system that includes different types of equipment from legacy to smart ones and gathering information from them. So data integration is one of the main challenges to implementing an IoT system. Another challenge is having insufficient knowledge of IoT integration because the integrators not only need to be familiar with system layers inside an organization, they must be skilled with real-time analytics and artificial intelligence. Another challenge regarding using IoT equipment is to have a reliable method for testing devices to determine if they are running the most recent firmware version, and if not, for installing new firmware. We can add this patch management to the schedule of the maintenance team to avoid interrupting operations. The destructive effect of IoT system failure is another challenge ahead of us. Any outage or breakdown in the IoT system can cause potentially fatal scenarios or significant financial losses. And the top potential risk of implementing the IoT system is the security issue. For example, it's rather usual for IoT devices to retain their default passwords even after being installed in the factory. And numerous IoT devices send data in plain text that a hacker can easily intercept to know what's happening. Due to the mentioned issues and more, a hacker can gain unauthorized access to the IoT system, not only putting the company at the risk of significant breach, but launching an attack to cause process disruption or sabotage. After reviewing different concepts of industrial IoT, do you, as a professional automation engineer, recommend using IoT systems in industries or not, and why? Please share your thoughts and experiences with us and the audience in the comment section. Also, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out-of-the-oven videos. This way, you keep motivating us to produce more informative videos.